Hey everybody. Today we're going to talk about converting fractions into decimals. Fractions and decimals are both different ways to write numbers, but there are fractions and decimals that mean exactly the same thing. Sometimes fractions are more useful, sometimes decimals are more useful. So it's good to be able to go back and forth between these. Today we're going to focus on the direction going from fractions to decimals. So taking a number that's written like the ones we have here and converting them into a decimal. So first, we've got to understand the different parts of a fraction. On top, we always have the numerator, right? So the numerator we have on top. Over on the left, we have 7. On the right, we have 1. And then on the bottom of a fraction, we have the denominator. 6 on the right and 8 on the left. And then in the middle of the fraction, we have that fraction bar. That fraction bar actually symbolizes division. So when we think of the fraction 7/8, what we really think of is we have 7 divided by 8, or 1 divided by 6. And that's actually how we convert fractions into decimals. In order to convert a fraction into a decimal, we take the numerator and we divide it by the denominator. That's it. So all we have to do is use long division in order to do this. So let's see what that looks like on a couple of examples. Alright, let's take a look at our first example here, example A. So example A says 7 divided by 8, right? That's another way to write this fraction. 7 divided by 8. So if we were going to write that out for long division, we would put the 7 on the inside because that's what we're dividing, and we're dividing by 8, so that goes on the outside. Now, this looks really tricky right here, because normally we try to think of where does the 8 go, right? How many times does the 8 go into the 7? And the 8 doesn't go into the 7 at all. But what we can do is we can put a decimal after the 7. And if we add zeros after the decimal, we're not really changing the number at all. 7.0 is the same as 7. And now we can think, how many times does 8 go into 70? Now, I know 8 times 8 is 64. So 8 goes into 7 8 times. And 8 times 8 gives us 64. Now we can subtract here. 7 minus 64 is going to give us 6. And I don't have anything to bring down here, but I know I need to bring something down when I'm doing long division, so I'm just going to add another 0. Bring that 0 down. I'll put the 0 right here. So now we're at 60. So now 8 times 8 is 64. So it doesn't go in 8 times. But 8 times 7 is 56. So 8 goes into 67 times. 7 times 8 is 56. And we can subtract that. So 60 minus 56 I know is going to give me 4. And I need to bring another number down. So I'm going to add another 0. Now this number is getting kind of long here, 7.000, but it's still the same. It hasn't changed in value. So we have a 0 here next to the 4. So we got 40. 8 goes into 40. Now I know that one. That's 5 times, because 8 times 5 is 40. So I get 40 here, and I can subtract those, and I get 0. So once we have 0, and we're all out of numbers up here in the problem to bring down, we're done. We just need to put the decimal place in the right spot. So when we're doing long division, the decimal just comes straight up from where it is in the problem. So the decimal goes right here in front of the 8, and we can put a 0 in front of that. And this is our answer here. 0.875. 7 divided by 8 equals 0.875. So let's try that again with our next example. We got 3 over 20, which is the same as 3 divided by 20. So I have 3 on the inside of my long division, and I have 20 on the outside. Now how many times does 20 go into 3? Not once. So we're going to have to put a decimal point and add a 0. So now we can think of this as 30. 20 goes into 30 one time. 1 times 20 is 20. We subtract, and that gives us 10. So I need another number to bring down here. And now I have 100. How many times does 20 go into 100? 20 goes into 100 5 times. 5 times 20 equals 100. So 5 times 20 is 100. We can subtract, and we get 0. 100 minus 100 is 0. And we have 0, We don't have any other numbers to bring down here, so we are done with the problem. We just got to put our decimal in the right spot. We bring it straight up, and we put a 0 in front of it. So our answer, 3/20, is equal to 0.15. These are equivalent statements right here. Okay? Same thing with over here. Now, these decimals stop at some point, right? 0.875. There aren't any other numbers after that. You know, we could say that a 0 is after that, but that doesn't really matter. So there's a special name for these decimals. These are called terminating decimals, right? To terminate means to end, and these decimals end. So they are terminating decimals. So right here, that's a terminating decimal. Over here, that's another terminating decimal. Now, some decimals are not terminating. We're going to see what that looks like in a second. Examples C and D here are going to show us what happens when decimals don't terminate. So C is 4/9. Example C is 4/9. Remember, that means 4 divided by 9. So we need to set up our long division. We've got 4 on the inside, 9 on the outside. So 9 goes into 4 0 times. So we're going to need to add a decimal point and a 0. We can even put a 0 above the 4 because 9 goes into 4 0 times. Now, 9 goes into 40. 9 times 4 is 36. So we have our 4 there. 4 times 9 is 36. We subtract. We get 4 here. And put another 0. Bring that down. Ooh, we got 40 here too. 9 goes into 40 4 times. 4 times 9 is 36. 40 minus 36 is 4. Put another 0 at the end here. Bring that down. Oh, we got 40 again. Wait a second. I've noticed a pattern here. I started with 40. I got 40 again. I got 40 again. If I keep going, right, 4 times 9 is 36. I'm just going to keep getting 40 every time, and then my answer up here is just going to keep getting longer. 4, 4, 4, 4. So what I can do is, I notice the pattern. I'm going to put my decimal here. And we can say our answer is 0.444, and then we show the dots, dot, dot, dot. That means that 4 is going to keep continuing. This pattern is going to keep going. 0.4 repeating is another way to say this. Another way to write it is 0.4, and we put the line over what's repeating. 0.4 repeating. And this is called a repeating decimal. And that is our answer for 4/9. 0.4 repeating. So we'll put a box around our answer down here. So example D, let's try this one and let's see what we get. So it's the same as 6 divided by 11. So we'll show that. 6 on the inside, 11 on the outside. Now 11 doesn't go into 6, goes into 6 0 times. So we'll put the decimal here, add a 0. 11 goes into 60 5 times because 5 times 11 is 55. So we'll subtract that. 60 minus 55 is 5. Add a 0, bring it down. Now I got 50. Okay, so this number is different. It's not 60 again. 11 goes into 50 4 times because 4 times 11 is 44. So we can subtract that. That's going to give me 6. 50 minus 44 is 6. Add a 0. Bring the 0 down, and we got 60. Okay, now that's what we started with, was 60. 11 goes into 65 times. 5 times 11 is 55. We subtract, it's going to give me 5 again. Put another 0. Bring that 0 down, 50. Oh, okay, now I start to see the pattern. We went 60, 50, 60, 50 again. 11 goes into 50 4 times. 4 times 11 is 44. I'm going to subtract that again and get 6. And I'm just going to keep going back and forth. So my answer here is that number continuing. So I know I'm going to get, we got to make sure we put our decimal right here, 0.5454. Could write it as 0.5454 dot 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 or 0.54, and since both numbers are repeating, we put the line over both numbers. So this is our answer for the second one. So for both of these cases, we get a repeating decimal. So on the previous two problems, we had terminating decimals, but here we have repeating decimals. So when you're turning fractions into decimals, you can either have terminating or repeating. It could be one or the other.